Should we standardize? I avoided preparing this lecture for a couple of days. Today, I was drinking some coffee and explaining to a colleague of mine, I really want to elaborate on standardization, but I don't think the students will be interested. Moreover, there is a dispute on the topic. My colleague then looked at me and said, then tell that to the students. Show them both sides. And that's how he closed the topic and got rid of me. So, to standardize or not to standardize? That is the question. Let's explore a simple example. Here's a scatter plot with 4 apartments. The x-axis shows the size, while the y-axis, the price. That's a very common regression relationship. But we are doing clustering here, so instead of causality, think about how we can group the 4 observations. A is a 500 square foot apartment that is worth $50,000. B is a 500 square foot apartment that is worth $100,000. C is 1,200 square foot apartment worth $50,000, and D has the same size but is twice as expensive. If we were to create 2 clusters just by looking at the plot, they are likely to be A, B, and C, D, right? Now, what if we standardize the x-axis, size that is? Without taking you through the calculations, that's the new situation. The x-axes of these points are either -1 or 1. How would we group them now? Well, AC and BD looks reasonable, right? Yes, it does. Finally, let's also standardize the y-axis, or price. Now, the y-axes are only -1 or 1, too. What we see is a perfect square. We have no way of deciding if the clusters should be AB and CD or AC and BD. So, we went from one solution, through a totally different one, to no solution whatsoever. Why did that happen? The ultimate aim of standardization is to reduce the weight of higher numbers and increase that of lower ones. Now, let's see the first graph once again. If both axes had the same scale, so from 0 to 100,000, we would get something like this, but even more dramatic. A k-means algorithm would immediately cluster A with C and B with D, just because the scale of price was so different compared to size in terms of mere numbers. So, scale matters. Finally, the last graph resulted in a square because there were only 2 values for each axis. Logically, every rectangle on a graph after being standardized turns into a square. So, no matter how I chose the axes or how far off they were from each other, as long as they were in the shape of a rectangle, the standardized output would have been a square. That said, by standardizing both axes, we remove the weight introduced by the high price values. To sum up, if we don't standardize, the range of the values will serve as weights for each variable. Price had much higher values, which would indicate to k-means that price is more important. This would lead to clusters based on price, AC and BD, the economy cluster and the luxury cluster. Note that the clustering would barely, if at all, care about size. So, if we don't standardize, we are not taking advantage of the size data whatsoever. Therefore, it is a good practice to standardize the data before clustering, especially for beginners. The final note I'll leave you with is when you should not standardize. As standardization is trying to put all variables on equal footing, in some cases, we don't need to do that. If we know that one variable is inherently more important than another, then standardization shouldn't be used. Our price-size relationship could be one of those. Most people are affected by the price much more than the size, aren't they? If you can't afford the price, you won't care about the size, right? How can you know that prior to clustering, you may ask? Experience plays a big role. So practice when the time comes. We will discuss this a bit more in the next lecture. Thanks for watching.